All right. So thank you all for joining our first session that will start going to machine learning after spending some couple of weeks trying to do learn Python so that we'll have somehow kind of smooth understanding of machine learning. So thank you all for joining. I believe now we have few people, maybe other people will join along the way. So Harris, you finish, we obviously did a lot of stuff. For people that have not been here, we finished, or we went through the book, 2 books. The first one is Python Crash Course, and the second one is Python Data Science Handbook, right?
Yes, sir.
And we learned a lot from them, and yeah, and also we went through Panda's Panda course, mini course from Kaggle, and a lot of you guys, you learn from that. And we started also 100 machine learning, 100 days of Python, which we have not continued, but we continue as we start doing this machine learning course. What we have not covered in the plan we intended to do is we have not covered GitHub, and also we have not covered how to use terminals. But I will share some resources that maybe people will try to use that thing to learn on themselves and ask questions if they have. So how are we going to do this machine learning study session? Previously, we intended to do different course from Microsoft Machine Learning for Beginners, but I felt applied machine learning by Andrew Muller is a good way to start because it combined with his book, Introduction to Machine Learning. So this is the book course I intended us to go through. This is a complete course of machine learning. It's a complete course of machine learning by Andrew Muller. Who is Andrew Muller? Andrew Muller is the or author of the book Introduction to Machine Learning with Python. This book that I shared, this one, he is the author of this book, and he graciously shared his course, the content of the course, the videos, and everything one needs to do. So for example, and the course is at the University of Columbia. You can see there are slides here. There is also video here from YouTube. So for each session, there is video and there is slide. Not only that, he has some recommended readings that you can follow along. What I mean by that is, for this course, we will be using 2 books. Introduction to Machine Learning with Python, which was authored by Andrew Muller, which is this book that I have shown now. Which one is that? Introduction to Machine Learning with Python, this one. And another book, which is called Applied Predictive Modeling. Applied Predictive Modeling is also a recommended reading for this machine learning course. So if you look at this one here, for you to go through chapter 1, he said, okay, read chapter 1 of Introduction to Machine Learning with Python, chapter 1, and chapter 1 and 2 to Applied Predictive Modeling. So this way, you are not only watching the lectures, but you go along, you watch the lectures, the explanation, and also you read the chapters from the book. These 2 books, I have already shared these 2 books with you. Okay, so if you look at this is a slide of his lecture. These are the books we're gonna be using. Introduction to Machine Learning with Python, Applied Predictive Modeling, and Introduction to Statistical Learning. This one is element of statistical learning, but we'll be using the other one, Introduction to Statistical Learning, which is not, this one is more deep and more rigorous and mathematical. The one that is somehow not deep is Introduction to Statistical Learning by the same author, but it's meant for people like for masters, but this one is definitely for higher people that have rigorous mathematics somehow. So this is a reference book that will be used in this course. So what the plan is that every day, Saturday and Sunday, we'll go through one session. So for example, today I will do introductory session. I will ask you that before each session, you watch the lectures. For example, now, this week, we'll just do introduction, basically to see how we can install the libraries we required. I will also go through chapter 1 of the introduction to Python with machine learning. So for example, we can discuss this one Saturday and we discuss this one Sunday. So each session, we are going to have 2 sessions. Each week, we are going to have 2 sessions. So, and I will ask you to watch the session here. You watch the video and read the recommended readings. So that way, okay, someone is making noise. Let me meet some other people. Right. So that way, what I will be using is I will go through the book. What I will be using is that we'll go through this book, Introduction to Machine Learning, because it is a main textbook here. It is a main textbook that's being used. So for first week, you go through and watch this video lecture. So let me show you how this is.
I'd like to get started. So
do you hear some of the audio from the video? Hello? Do you hear the audio from the video?
Yes, sir.
Yes or no? Okay. Right. So you watch this one, but what I'll be doing is, instead for us to go and repeat the video, the content of the lesson, when you read the lesson, when you watch the video lecture and everything, we'll come to the week and answer some questions that you have, and also ask a question in the group. But what I will be going through essentially is to go each chapter in the book. So we can do introduction, supervised learning, unsupervised learning, all these chapters. I will go through this book from the chapter 1 to chapter. It has chapter 1 to 8, from 1 to 8. So I will go through chapter 1 to 8 of this book, while you are going through this session and everything. So whatever we go through that in chapter 1 to 8 will be something just replicate of this one, but you are getting more explanation also from the author of the book. I have shared this book, Introduction to Machine Learning with Python. I've also shared Applied Predictive Modeling. These are the 2 books. So for example, I have made mention for the first week, introduction, you read chapter 1 of Introduction to IMLP, means Introduction to Machine Learning. AMP means Applied Predictive Modeling. So read chapter 1 and 2 of that book and read chapter 1. For the next session, for example, multiple, this is what is recommended. For this one, read this chapter. This is the reference chapter, and this is a video, and this is a slide. So this is how. So there are even homeworks that this homework will actually pose you to try to solve the issues, problem, and to actually nail your understanding. So this is what we are going to use this one, but also, as I said, we'll be going through the book. Now, does anyone does not have this book? I share the book, this one book. Anyone without this book? Anyone without this book? So I believe all of us, we have this book, right? Is that correct?
Yes, we do.
Okay, so Let's get started what we'll be using. So today what we'll be using is just an introduction. This is introduction of the first chapter of the book. We go through, today is just introduction and what is machine learning and how we can install the basic libraries that we can use. So this goes from here. This is just a recap of the book. Is the something I just pick up the some part, but you can also get it. Let me show you from GitHub. So here you can come here and say, okay, right, okay, this is it, I guess. Right, no, this one. Machine learning with Python and Remula. So this is GitHub. Okay, let me see GitHub. Okay, so for those without the book, we'll share the book in the group. So this is a GitHub repository for the book applied that we'll be using. I will share the GitHub. So this is a GitHub repository. What this means is that all the codes in the book is here in this GitHub repository. Now, we have not actually discussed on how we can use GitHub, but how can you take these files from GitHub to your computer? I will show you how to get this one. So if you want to get this into your computer, we all have what is called terminal in our computer. We all have what is called terminal. Let me show you something. So you know all this one, right? This is terminal in our computer. We all know this one, which is terminal. Now, for you to get this repository, which is GitHub, if you don't have GitHub account, create GitHub account. I will share what you should use to get create GitHub account. Just go to this website, GitHub. This is a GitHub. So if you come here, this is a GitHub. No. Sign in GitHub. So this is a GitHub. You can sign up for the GitHub account, sign up here, and we'll explain how we can use that. So if you want to clone this one, there is what is called cloning repository. You can simply download this one to your computer. When you download this, then you're gonna download everything here. Everything here, you're gonna download it. So I've already downloaded it and open it in using my VS Code. I believe we already know how we can use VS Code in our previous sessions. So let's get started and know what that is about. So after you download this one, or this GitHub repository, so this, you will see it here. I downloaded it now, and I have all the files on my computer. If you don't know how to do that, let us know after. So let's go on and see what it's all about. So we already know machine learning is now integral part of everyday aspect. So from Facebook, Twitter, Instagram, everything that you use is about machine learning. For example, in Facebook, you can see friend recommendation. For example, if there are two people, A, B, and C, and A and B are friends, B and C are friends, then if A and C are not friends, you see Facebook will try to recommend Mr. A that he should be friend with Mr. C. This is called recommendation, and this is an act of machine learning. So everything now in this real world is becoming with this machine learning. This book that we are going to use, the Introduction to Machine Learning, is basically the basic machine learning. What we mean by basic machine learning is that the book does not actually contain a lot of mathematical algorithm, because machine learning concerns with probability and a lot of maybe linear algebra stuff. So this book is just an introduction, and it does not actually describe the detail of machine learning, but it will just give you the model using a package called Scikit Learn that allows you to do machine learning. So sometimes machine learning become difficult for other people to do, because there are a lot of mathematics, there is a lot of statistics, there are a lot of other things. But this book takes a gentle approach to teach you machine learning from the applied perspective. When you learn from the applied perspective, then you can now go back and learn the detail of the machine learning on algorithm, how it is implemented. Now, so what is machine learning? So machine learning in its simplest term is just extracting knowledge from data. Extracting knowledge from data. So for example, given an email, detecting whether an email is spam or not, we can use machine learning. Given a Twitter, detecting whether a tweet contains sentiment, positive sentiment or negative sentiment, we can use machine learning. Given a Twitter tweets, you can determine whether a tweet contains hate speech or not. Given to, for example, a medical field, you can determine using machine learning whether an image contains brain tumor or not. All these things is we can be machine learning. So machine learning is just extraction of knowledge from data. And it is a research field in the intersection of statistics, artificial intelligence, computer science. All these are part of machine learning. With this book, you don't need to be expert in statistics. You don't need to be expert in computer science. You can get started in a bit. And also machine learning is called predictive analytics or statistical learning. So sometimes you see people, they are saying predictive analytics or statistical learning. So when people say statistical predictive analytics or statistical learning, what they mean is machine learning. So that is why if you see this one here, the book here we are doing machine learning, Introduction to Machine Learning, but the book recommended by this one, you can see that we have two books. The first one, Applied Predictive Modeling. It is saying Applied Machine Learning. Can you see that? Also, the other book we have, which is I already shared with you, An Introduction to Statistical Learning. Statistical learning here means machine learning. So when you hear somebody said predictive analytics, or someone said statistical learning, or someone said machine learning, all these things are the same. Just the nomenclature. However, there is deep learning. So this is deep learning. This is another book of deep learning. So deep learning is a subset, part of machine learning. So for example, machine learning is a large umbrella, while deep learning is some kind of subset of machine learning. So it is good idea for one, before you start learning deep learning, to start learning machine learning. Then you can move to deep learning. So it's just like baby steps. So you learn from the beginning, then you move. But some people will just move to start learning deep learning without machine learning, but it is possible, but they will have some kind of really things to better to understand. But when you learn machine learning, a lot of concepts that are being used in deep learning, you see them in machine learning. So that is why for this session, there are a lot of other colleagues here that we wanted to start doing deep learning, but we'll start basically with machine learning in a couple of 2 months. I think we can finish with this one. And I believe if you really focus on this course, applied machine learning, you will get up to speed on how to train any machine learning algorithm. Any machine learning algorithm with this applied machine learning, using these books, Introduction to Machine Learning, using the other book, this one, Introduction to Statistical Learning, which is the second edition, and also the Applied Predictive Modeling, these 3 books, which I share, which will apply predictive modeling. These 3 books, when you focus on them, you will learn everything you need for machine learning, everything you need for machine learning. So unfortunately, this one, Applied Predictive Modeling, is not in Python, rather it is in R. But what we will be understanding in this book is just like the concept. We are not using this book. So you can see this book is also introduction, terminology, a lot of stuff. The main book we will be using is this, Introduction to Machine Learning, Introduction with Python. But the other books can serve as reference. For example, when we discuss what is classification in this book, so this book may not discuss classification in detail. Then you can look at this book, what is classification, or some stuff, you can look at it as a reference. So you can move through along the books. That is why the author, he recommended, you can see, as I made mention, in each chapter, in each week, we have the recommendation whether introduction to machine learning with Python and also applied predictive modeling chapters. So you read these chapters for each week. So for those that have just joined us, let me recap what we have said. We are going to start doing machine learning course with this course, Applied Machine Learning. This is a course by Andrew Muller from Columbia University. Each week, we will be meeting on Saturday and Sunday, and hopefully we'll be discussing one session. Before we meet, you are expected to watch the lecture videos, because if you click here, it will take you to YouTube. If you click here, it will take you to YouTube about the introduction, about this session, and this is slide. If you click here, it's a slide. If you click here, is the video. And these are the readings for this session. And these are some homework. These are the recommended reading for the book. So we are using this one just to go through over them with yourself and everything. If you have questions, when we come for the session, we'll try to answer some of the questions that you have after reading this one. But what I will be discussing each week mainly will be the content of this book, Introduction to Machine Learning with Python, which is what I'm doing right now. This is it. So this is from the Introduction to Machine Learning. So yeah, we stop at here. What is machine learning? As I said, machine learning is just about extracting knowledge from data. And it is also called predictive analytics or statistical learning. That is what it mentions. So why machine learning? Now, previously, there is in early days, that is called intelligent application. Sometimes in early days, you will see that this is an intelligent system, intelligent robot or something like that. The word machine learning has not been used previously, just intelligent, we use intelligent. So how the intelligent system works previously? So the way intelligent system works previously is using what is called rules, hand-coded rules. So for example, if I want to detect whether an email is a spam or not, what I can use is this. I will sit down and say, if the content of the email contain Nigerian prince, then classify this email as spam, else not spam. If the email contains the word maybe Nigeria, classify this email as a spam. Else, if it does not contain Nigeria, it's not a spam. This is called hand-coded rules. What we mean by hand-coded rules is that you previously specified what you want your system to do. So why is it intelligent? So if somebody automatically sends you an email and you already specify that if that email contains Nigerian prince, I know you all know those kind of email that says Nigerian prince, which are spam. Now, you already specify hand-coded in your program that if the email comes with Nigerian prince, then say this is a spam. So you can see this is called intelligent system. But you hand-coded with the rules. You specify the rule. If this is a spam, if it contains this is a spam, if it contains this, this is called hand-coded rules. But this hand-coded rules has some disadvantage. Number one is that you need to have understanding of the domain. For example, if I want to classify email which is spam, then I must know what classifies something as a spam. If someone is living in England, he may not know that Nigerians content like Nigerian prince or something like that. So you should know what kind of rules you should specify, which is really, and when you change from one domain to another, you need to rewrite the whole rules. So that is some of the problem with intelligence system. Now, what we want an intelligence system that we don't need to write a rule. It will automatically learn to classify, this is a spam, not a spam. Without you writing, if this email contain Nigerian friends, this is a spam. If this email contain Nigeria, this is a spam. So you need to specify many rules. If there are 1 million rules, you need to specify if else 1 million. But this is tedious. And if you change from emails domain, maybe to some another domain like tumor, you want to classify image if it is tumor or not. Now, if you are an expert in the medical field, you already know that when we see some kind of lesion, this is a tumor. So you can write code that if this lesion appears in this image, then this is a cancerous, something like that. You need to spare all those images. But this is tedious and we cannot secure. So we need an automatic way that we need to automatically learn from these kind of rules without specifying rules. That is called machine learning. So we have different kind of machine learning. That is when machine learning comes. That is, it means machine learn on itself automatically without being programmatically specify the rules. So here, if you can see in intelligence system, you specify the rules. You say that, okay, if this is this, then you give the rules. But we need a system that we don't need to specify the rule. We want the system to automatically learn on itself. So how can you do that? What I'm saying is that just give the system emails. If the email is a spam, it will classify it as a spam. Without telling the system that if it contains Nigerians as brains, or if it no, you just give it emails, it automatically spam. This is machine learning. Trying to learn from data automatically without being programmed. That is called machine learning. But we have different kind of machine learning. In a simplest term, we have supervised learning, and we also have what is called unsupervised learning. Before we continue, any question? Before we continue, any question? Any question before we continue? All right, no question. Okay, so what kind of problem machine learning can solve? So we have two different kinds of machine learnings at the basic level. We have what is called supervised learning, and we have what is called unsupervised learning. Now, what is supervised learning? A supervised learning is one in which you teach the model how to learn. So this is how supervised learning works. So for example, I want to train machine learning that can classify something as email as spam or not. So what we can do is this. You get your data and annotate the data and classify all the data, the emails that are not spams, that are called input. And you have all the emails that are spam, that is called output. So in supervised learning, you teach the machine that this email are spam, this email are not spam. You give it to the machine. Yeah, you give it to the machine and say these emails are spam, this email are not spam. So you give it to the machine, give the machine 10,000 emails that are not spam. Give the machine 10,000 emails that are spam. So you give the machine input and output. So you are telling the machine to learn whenever you see this kind of emails, they are not spam. Whenever you are seeing this kind of email are spams. So the machine will learn automatically from this input and output. So next time when the machine learns, you just give the machine any emails, whether it is spam or not, you give it and ask the machine, tell me which one is it? Is this spam or not? then the machine can be able to classify that email as whether it is spam or not. This is called supervised learning. In essence, supervised learning is something that you are teaching the system. Like, for example, a small boy, you teach him that, okay, this is food, this is not food. This is fire, this is not fire. This is a shoe, this is not a shoe. So small boy will learn along the way. So this is called supervised. Why is called supervised? Because you are teaching the machine. This is what it is. Now, the second one is called unsupervised learning, in which you don't give the machine output. You only give the machine input data. So you can see here, example of supervised machine learning tag include identifying the zip code from handwritten digit and envelope, determine whether a tumor is benign in a medical image, detecting fraudulent activity in the credit card. All these are examples of supervised learning. You give the machine input and output. That is, you train the machine learning. In unsupervised learning, the laborious task is, before you do supervised learning, you must manually try to annotate your data. So for example, when you have 10,000 data, you need to sit down first and classify, okay, this is, for example, this is fake, this is not fake, this, you need to do annotation. That is called annotation. That is the manual laborious process in supervised learning. You need to first annotate your data, divide it into two, input and output. But in unsupervised, you don't have output. You only have input. You only give the machine learning the data. You don't train it based on input and output. You only give it input and try to learn from it. That is called unsupervised learning. So only the input data is known and no non-output data is given to the algorithm. While there are many successful applications of this method, they are usually harder to understand and evaluate. So supervised learning is easy to understand and also easy to evaluate its performance. But unsupervised learning is not easy to evaluate its performance. So some of the examples of unsupervised learning: identifying topics in a set of blocks first. So what do you mean by this? Maybe you may be given 1 million block post or 10 block post, and you ask, identify which topic this block is written. Then the machine learning algorithm will, okay, this is about politics. This is about university. You can see in this case, the prediction, you do not train the model based on saying that this is a block about the politics, this is the output. You know, just you give it the data set to learn to classify. So basically, these are two kinds of machine learning: supervised learning and unsupervised learning. And this is what will be learned in this book. Right. Any question before we continue? Okay. Right. So now, having understand that machine learning previously was called, we call it intelligent system, where we use hand-coded rules to actually specify something. Then we have machine learning problem where we want to automatically predict or classify something, and the machine learning problem is classified into supervised learning and unsupervised learning. In supervised learning, the thing is, we have input and output, while in unsupervised learning, we only have input, we don't have output. Now, let's move on to knowing your tasks and your data. Now, what I would like to ask that if you want to do machine learning, whether it is a project or anything, what you need to do first is you should have your data, know your data. Don't say you want to do machine learning and you don't have your data at hand. So when you are doing a project now, maybe master's project or undergrad project, and you say you want to do machine learning, the first thing you should spend your time is find the data that you will work on for your project. When you find your data, know that data and whether it can solve the problem you want to solve in your project. Because each also algorithm, a machine learning algorithm, works best for a particular data. So it is quite good to know your data before you even start doing your machine learning stuff. Now, for example, when you try to do machine learning, these are some of the things you should have. What question am I trying to answer? So, for example, you collected data and you want to predict whether you collected tweets and you want to predict whether that tweet is negative or positive. So now, what question are you trying to answer? So after you collect your data, try to figure out what are the questions you want to answer. So let me give you an example. I want to do machine learning on tweet data, Twitter. Now, the first thing I want to do is don't even try thinking about training the machine learning model. What you start thinking about, figuring out, how can I get my data? How can I scrap data from Twitter? In other sense, you don't need, maybe sometimes you don't need to get your data. You can get off-the-shelf data. There are some data available, machine learning data, we'll see some of them. So you can get those one. If you get your data, then know the data. Now, if you get the data, then start asking, what are you going to ask with your data? So I want to ask, okay, this is a data, tweet data. I want to do sentiment analysis with it. So what I want to do, I want to find out whether these tweet are positive or negative. I want to find out whether this tweet contain hateful content or not. I want to find out a lot of this kind of question. So these are some of the questions that you actually want to ask, and we will look at them when we start doing the program. Now, why Python? So Python become actually the lingua franca for any machine learning data science. And that is why the books chooses to use Python. And that is why we already spent some time trying to learn the basics of Python. That is why we did 2 courses, 2 books, Python crash course. If you have not actually been good, don't have quite a little background in the Python, I will urge you follows through that book, Python Crash Course book. It will give you a really, really good understanding background of Python. And also we have seen Python Data Science Handbook, where we discuss a lot of stuff. So the reason why Python become it's general purpose programming language. You can use scripting, and also you can use it for data science. Unlike other R and Matter, like R is not general purpose programming language, it's statistical programming language. So R is very, very good in doing kind of statistic data analysis. That is why in some ways doing doing data science and statistical analysis, R is also good. I really, really like R in doing statistical analysis. So, but we are using Python. Now, Scikit Learn. So what is Scikit Learn? Now, for you to do machine learning, there are many algorithms. So those algorithms can range from supervised algorithm and unsupervised algorithms. Since we said we can do machine learning through supervised learning and unsupervised learning, then there are a lot of algorithms that are in supervised learning and unsupervised learning. But Scikit Learn is a Python package that implements nearly all the machine learning algorithms. You don't need to implement machine learning algorithm yourself. All you need is just to use a package of Scikit Learn, and you can use machine learning. So let's look at what is Scikit Learn, sklearn. Right, so this is Scikit Learn. This is the most widely used machine learning package. Most widely used machine learning. When you learn Scikit Learn, when you have a good understanding, you can do anything you want to do with machine learning. So we will have reference at this one. So the author of this book that we are going through, he's one of the core contributor of this package, Scikit Learn. So you can see, you can use classification in machine learning using Scikit Learn. Classification is given 2 things, identify which category. For example, you can classify image as tumor or not. That is called classification. We'll see the detail. Regression, predicting continuous value. And clustering You can see them: dimensionality reduction, model selection, pre-processing, a lot of stuff. This is called Scikit Learn, and we'll see how we can use Scikit Learn. So let me show you just an example on how you can use Scikit Learn. For example, now let's look at linear models. Just an example, for example. So if you want to use Scikit Learn to just okay, so if we want to use Scikit Learn just to make like prediction, something like that, this code, only this section of code allows you to do prediction in machine learning. You don't need anything that's so complex. You can see that only this code, you import some stuff, all the algorithm, linear regression, you can see that you can do a lot of stuff. So all this one are machine learning algorithm implemented in, you can see them, linear regression, Bayesian, a lot of stuff. If you look at the regression as well, I look at the regression. If you look at the classification, you can see it. We have a lot of stuff. SVM support vector machine, which is machine learning algorithm, stochastic gradient descent, nearest neighbor. Can you see that? So let's look at SVM, which is machine learning algorithm. So if you want to do classification, one of the algorithms that can use for classification is SVM. And you can see that this is, for example, using SVM. So this is the code you can use just to do classification. Some of these are just, you can see it's not like such kind of large number of code, just simple code. That is why Scikit Learn make it easy to use machine learning. Without Scikit Learn, you need to implement all these algorithms from the beginning using programming language, but this Scikit Learn abstract the details for you to use any machine learning. Any question before we continue? So I will share the Scikit Learn. Okay, I shared the Scikit Learn, I guess, already. Okay, let's continue. So you can see this is Scikit Learn, and we will go through details of Scikit Learn. So this book that we are going to use, Introduction to Machine Learning with Python, solely use Scikit Learn. It uses Scikit Learn, but you can also use machine learning using other package like Keras. Let's look at this one. What is Keras? Let's look at this Keras. So Keras, you can see, look at is Python deep learning framework for that has been implemented in Python. Not only Python, you can also use, let's look at this TensorFlow. So you can also see this one is, we have TensorFlow here you can use for machine learning. We have many framework, PyTorch. We have PyTorch framework as well. If we look at PyTorch from research. So these are framework that you can use for deep learning. For example, PyTorch, TensorFlow, Keras. But for machine learning, that is what we will start doing. And we will move on from machine learning to go and learn some of these deep learning stuff like Keras or TensorFlow or PyTorch. But at the beginning, for doing machine learning, we'll do Scikit Learn, and we will learn a lot when we have the basics. So that is it. Scikit Learn is a very popular tool and most prominent Python library for machine learning. It is what it is in industry and stuff like that. Now, installing Scikit Learn. How can we install Scikit Learn? Right. So all the things that we'll be using in this course, you can install them using. So I share this one. This is the, because we have many packages that we can use to install to run to use this one. So we can actually share, install the package we can use using two ways, using Conda or using pip package. So do we all know what is the meaning of pip and Conda? If you don't know, just answer right in the channel. Do you know how to install package using pip or Conda? Hello? Okay, right. Okay, so how can you install packages in Python? For you to install packages in Python, we use what is called Conda or pip. So this is how, for example, let me show you this. Okay, right. So a lot of us know how to install, do installation in Conda or pip. So what I will urge is to, if you don't know how to do that, it is one of the things I would recommend is to install Anaconda. So when you install Anaconda, all the machine learning packages like Scikit Learn, like NumPy, like Pandas, they have been already installed together. So you don't need to do that. But if you don't know how to do that, what I can urge is this. Okay, someone has a question? Okay, all right, all of us know how to do that. So let's move on with that. If we all know how to install the packages. So if you want to install all the packages that I use in this book, is if you are using Conda, you use this instruction, Conda install this will install all the package. But if you are using pip, you can use this one. Yeah, but let me just show if some people have a question on regarding to that. Let me just show that a bit. So this is my terminal. And one good thing before you start doing any kind of machine learning or some stuff, that is what is called environment that you can create with what is called Conda or pip. Now, if you want to install package, there are two ways. Number one is called Conda. You can say Conda install. You can specify that what you want to install. For example, I want to install Scikit Learn. So here it means Conda install Scikit Learn. I'm installing Scikit Learn. Or you can use what is called pip install. Pip install, install Scikit Learn. You can install Scikit Learn with pip. So there are two ways, anyone you want. So for example, here I can say Conda install Scikit Learn. Scikit Learn. So when I enter here, this will install Scikit Learn for me in my package. Yes, Zaradin has question. As I ask you a question, Zaradin. Yes, Zaradin has question. Answer your question, Zaradin.
I want to make some recommendations regarding installation using Conda or pip.
Yes.
Like for me, I have been using Anaconda for almost 2 years. So I think for us that are living here in Nigeria, and sometimes we are found it difficult with issue when we are dealing with data issues, that is internet connection. It is better for us to use Anaconda. Once you install Anaconda, there is no need for you to install other packages because all the machine learning packages have already been installed if you are using Anaconda, unlike VS Code, whereby you have to install packages one after the other. That is my recommendation. Secondly, there may be a situation like me. There may be a situation whereby you find it difficult when running some models using Anaconda as well. So can you introduce like Google Colab to us so that me and my colleagues can also understand much about Google Colab, since it is a virtual GPU. That will also help us.
Yeah, right.
It's just a recommendation.
Right. Okay, so you can see here, I've already said recommended to install Anaconda or Mini Conda. So what is the meaning of this? What is the meaning of this? I already said recommended to install Anaconda or Mini Conda. So you can come here, Mini Conda. For example, you can say install Mini Conda, install Mini Conda. So Mini Conda is a lighter version of Anaconda. Anaconda is so large. Anaconda. So get started. So for example, what are the meaning of these two things, Mini Conda and Conda? So this is it, just get it this way. when you want to do machine learning, you need to install a lot of packages. For example, let me show you this. You need to install matplotlib. You need to install funders. You need to install numpy. You need to install Scikit Learn. You need to install this, that, a lot of them. So instead for you to install those packages one by one, for example, that I showed you here, for example, Conda install sklearn, Conda install pandas like this. For example, instead for me to do this, when you install this mini Conda or Conda, then they are automatically installed. So mini Conda or Conda, what they do is that they install required data science packages for you, so that you don't need to install them one by one. So here, because I'm using Mac, it download. So what you need, just download. If you are using Windows, just come here, download it. So you download for Windows. This is if you are using 64-bit, download it. If you aren't, download it. If you are using Mac, you download it. If you are using, you download it. This means that when you install Anaconda, you don't need to install these packages, because these packages, for you to install one by one, you must have internet connection before you install. But when you download this Anaconda, then you are automatic. But if you don't have much space and you don't want to install, so you look at them: Jupyter, SciFi, Spider, NumPy, Dask, Number, TensorFlow, PyTorch, Conda. All of this one will be installed. So you will have something like this. But if you don't want to install the large stuff, Mini Conda is a free minimal install for Conda. It is a small bootstrap version of Anaconda that includes only Conda, Python, the packages they depend on, and small number of usable packages. So it does not include many other things, Mini Conda. So you can install it. So if you, I think what is recommended now, you can install Anaconda. If you have a good internet, it will take a few bytes, you install it, then you are good to go. If you don't know, there is also what is called package management, environment management in Python. So what do you mean by environment management? So let me give you an example. So let me give you an example. So in Python, there is a notion of what is called environment. So what does that mean? So in Python or in machine learning, if you want to work on a particular project, for example, I want to work on a particular project that requires Python 3.5, because Python has different version, and all these packages also have different Python version. Let me show you Python version. You can see here, I have Python version 3.5, version 3.6, version 3.7, version 3.8. Can you see them? A lot of versions. Can you see a lot of version of Python? You have a different version. Now, there may be a situation whereby your projects only support Python 3.1. Another project you are working only support Python 3.6. Another project you are working on only support Python 3.9. This means you need to have multiple Python package in your computer to be able to run multiple projects. Not only Python, but also some other packages. For example, we have pandas, maybe 3.1, 3.2, something like that. So some projects, they may only support particular version of your project. So that means since you have different kind of version of Python libraries, then you may need to create some environment where you will only have different Python versions. So in that case, there is what is called Python environment managers. Python environment managers. One of them is Conda, and another one is pip. So here you can see I create a environment called data science. So all my packages for doing basic data science, I installed it in this environment. So there are two package environment. Let me show you. Yeah, I have this one, not this one. Yeah, so this an example. We have Conda, we have pip, we have virtual environment. These are things that you need to know. Conda, when you install Anaconda, or when you install mini Conda, you automatically have Conda installed. Now, Conda can be used to install packages. Can you see? Now, what can you use with Conda? Install packages. So if I want to install package with Conda, I would just say, okay, this is how. So you say Conda install. If I want to install package, maybe NumPy, I say NumPy. Can you see that? This will install NumPy package for you on your computer. But you can use another manager, which is pip. Can you see? Pip install, package name. Conda install, package name. So it means in Python, you can do installation in Python using two things, using Conda or using pip, right? Before you use Conda, you must install Anaconda or Conda. When you install Anaconda or Conda, then automatically you can use this command. You can use this command Conda install. But also you can install pip. So you can see that update package. So if I already install NumPy, I can update it like Conda update, I can say name, then environment or something like that. Update package, a lot of stuff. So you can also create a package name. So I gave you an example that you may need to use Python 3.5 or Python 3.6 in some project. Then it means you need to create an environment. So how can you create an environment? This is how you create environment. Can you see it? Create Conda, create name, environment name, then Python, the version of the package. So you can come here and say, okay, I want to create an environment. Conda, you type this, Conda, create minus name. Just this one is just how it is. But here you need to put the name of the environment you want. For example, I want to create an environment called Machine Learning ML Data Science. This is the environment I want to. Then here you can say Python. You can say, okay, Python 3.5 or Python 3.1. This one will create an environment called MLDS and with Python 3.1 in it. So if you have this, you can say, okay, create this environment with this, and this will automatically create an environment called MLDS. It will get, so can you see now? It automatically create an environment called an environment with Python 3.1. So that is how you can use Conda to. There are a lot of stuff I share here. I have something like this. I will share this one so that you will have an idea how to create. This is a link. I will share it as well. You will learn a lot how to create. So for example, now, if you look at this one here, I'm now inside an environment called data science. So if I click here, I can say, okay, deactivate. If I want to go out from this environment, I will say deactivate data science like this. Is it correct? Deactivate data science. Deactivate data science. I don't know what is happening. It's not showing. Is it not correct the way I write it? So this is it. If you want to activate, this is source deactivate Conda, deactivate Conda. Yeah, it's deactivate. So if you have data science here, let me see. Source. Sometime, okay. So sometimes if you look at this one here, for Linux and Mac OS, you need to use, if you want to activate, you say source activate. And if you want to activate an environment, you can use just activate. But if you want to deactivate an environment, you need to say Conda deactivate. Can you see just this? So in previous one, you can provide the name of the environment. So here we can just say Conda deactivate. So you can see now here, I go out from the data science. If I want to activate data science, I can say Conda activate data science. Conda activate data science. So now you can see now, I will now enter data science. So everything now, if I install everything now, will be in this environment data science. I can install Python 3.1, 3.2, anything. And any package now I install in this environment, it's now isolated in this environment. Yeah. So this one I will share with you. there are a lot of stuff you can learn from that. Yep. Yes. Oh, I already shared. So you can see here, you can install package, Conda install package, Conda update package. On install package, if you want to create environment, this is how you do a lot of stuff. So if you want to list environment, you can say, okay, Conda info environment. So here, if you look at this here, I can say Conda emp. So if you press enter here, this will lead the, oh, I'm already inside this environment. So you can see these are my environment: deep learning, data science, PyTorch. These are a lot of my environment. So we'll look at, you can look at this one, how this is done, but this is for you to do machine learning. So what I will argue is this: first, create an environment called any name. Just create an environment in your computer using Conda. After you create the environment, then come and install all the packages needed. So what are the packages needed for this course? These are the packages. These are the package using Conda. Yeah, these are the package. Oh, okay. We already assumed that you install Anaconda, but if you do not install Anaconda after you create the package, after you create the environment, you can go through and install using this information. Let me share the information and install it. Right. Any question before we continue? Right. And the other person asks how we can use Colab. So there is another thing called Google Colab that can be used to do machine learning and deep learning. Now, what is the meaning of why would we need Colab? Right. So why do we need Colab? Sometimes in deep learning, you need what is called GPU. And GPU, not everyone has access to GPU. It's a kind of resources, compute resources that is being used to train machine learning and deep learning models. Google provide free GPU through this, what is called Colab. But for you to use Colab, you must have internet connection. This is done in internet. You don't need to use, even if your computer has 2 gig RAM, 4 gig RAM, you can use Colab and train your machine learning online. But be mindful that you need internet connection in Nigeria. So for you to, you can do machine learning now, not in, for example, BS Code. You can use your machine learning in Colab, but you must have internet connection for you to do everything. Yes. So I share this one. We will see. For now, we may not use Colab, but when we come to do maybe deep learning, we'll definitely use Colab because people will not have access to GPU. So you can see this one, it explains what Colab is, what is the idea. But for now, we'll be using the Jupyter that we have on our computer because it is easy. Everyone, when you have a computer, even if you don't have internet connection, you can use Jupyter. Yeah, that is that for that. So yeah, so that is what we have now. There are other things that we need to know. We already understand what is Jupyter Notebook. This environment we are working is Jupyter Notebook. And these are some couple of Python packages that will be used in this course. Python, NumPy, we already know what NumPy is in our previous Python sessions. We will use SciPy. We already know what SciPy is. So SciPy is actually a Python package that contains some kind of scientific stuff. We will also use not only SciPy, we will also use Matplotlib. Matplotlib is Python package basically used for doing plotting, Matplotlib. And also we will use Pandas. We have seen Pandas in our previous session. Pandas is a Python package that is being used for data and data munging and some stuff like that. Also, there is another one, which is mglearn, which is one of the package that is being written solely for this book. We'll see it. The book also discusses Python 2 version Python 3.7. So this book will be using Python 3. So when you install your packet Python, we believe you have Python 3. So make sure that you have Python 3. So this today is just to introduce what we'll be using in this book, and also to show us what how we can install this stuff. So tomorrow we'll go through the first example to train our machine learning. This is just an introduction to see what it works. But what I want all of us now to do before tomorrow is install all the package, library, Scikit Learn, everything needed, install them, so that when we come tomorrow, as we are doing, you will be also practicing the machine learning as we run it. So any question? Any question? Right, no question. So what we have done now is basically, if you look at this book that I shared, you can go through it. This is what we have done. This section, introduction. So we have not started in machine learning. These are why machine learning. These are essential libraries that we need to use for this one, which are Jupyter Notebook, NumPy, SciPy, Matplotlib, Pandas, this one. And tomorrow we'll look at the first application doing machine learning, this one. Then in subsequent week, we will start doing supervised learning, unsupervised, as we have discussed what is supervised, just introduction, but we will see the details. Supervised learning, you can see many algorithms that are supervised. K-nearest neighbor, linear model, naive bias, ensemble, decision. These are all supervised learning. We'll also see unsupervised learning algorithm. You can see here, like K-means, a lot of clustering and stuff like that. So this is what is expected. Any question? And also, you should also try to, as we say, we're going to be using this course, try to watch this chapter 1, this one, introduction here, this introduction. So try to watch this lecture video, do chapter 1, read chapter 1 of Introduction to Machine Learning with Python, and read chapter 1 and 2. That is the reading for this week. This is the reading for this week. For the next week, we may probably jump into this section and also this section. But for now, this week, we should try to read this chapter 1 of this book. Let me share the other one. So for the other book, I want the other one, which is Apply Predictive Modeling. What is it said is read chapter 1 and 2. So this is chapter 1, introduction. This is chapter 2, short tour to predictive modeling process. So this just gives you a short tour of what predictive modeling process is, how it has been done and stuff like that. Just read it, you will get a good understanding of what is, so for example, data splitting, predicting, a lot of stuff. So read this one. So you can see it just few pages, 305. Yeah, just read it. And chapter 1 also is few pages, I think. Yeah, just read it. Yeah, and this one is just introduction, chapter 1. So that is that about the first session. This week is basically an introduction on how we can get started. The subsequent week, that is when we will start doing the real machine learning. Any question? Do we all know how we can do the installation? All the packages we have seen?
No, I thought you said if someone installed the Anaconda version, they don't need any installation.
Yeah, so even if you install Anaconda, there is one thing you need to install. What you need to install is this. Let me show you. Let me show you. So even if you install Anaconda, you need this. I think, right. Okay, so because the books use something, we will see it in the later section of the book. There is something, this one, which is not actually part of Anaconda. This one, this packet, mglan. Look at this one, mglan. Can you see this one? It's not part of the Anaconda, but just do that for now. Just do that for now. We will not see this one for now. When we come, we can install it separately. But just install Anaconda or Conda. That is fine. Just get started. So what I would urge you is that just get started. clone this repository if you, but I will also share mine because mine added some part of the session, part of the book. But this one, if you look at this, for example, Introduction Chapter 1, look at what it is. It is only the sections. You can see it, why machine learning. There is no detailed explanation, but I just grabbed the details from the book and put them. So you can grab this one. And how can you download this one if you like? You can just say download the zip. When you download the zip, you can open it in your computer. So Jupyter Notebook, obviously, some people may not be using VS Code, but they will be using Jupyter Notebook from browser. That's fine. Anyone you want to use, it is okay. I've already shared some. If you don't want even Jupyter, you can use Jupyter Lab now. Jupyter Lab. Jupyter Lab. Yeah, so this is Jupyter Lab. You can install Jupyter Lab. So this is, maybe I think this one, if you have not been using VS Code, you can use Jupyter Lab. So you can install this one, install it. So this one is something not in browser. It's an application that you can install. So you can install Jupyter Lab if you want, but some of us, we have been using now VS Code. That is fine. Yeah. Any question again? No question? Right. So if there's no question, I think we are now. All right. Okay. I want to say something also. So for people that have not actually joined us while we did our Python sessions, so you can see here, people are using here now pip install. So you can use either pip or Conda to do installation. So for people that have not joined us for introduction, these are some of the tutorials that you can get up to speed with the packages we said are needed for the course. For example, here you can see we said some of the package we need. We need NumPy, we need SciPy, we need to use Pandas, we need to use Matplotlib. So if you have not actually have those learn or those things, you can do some kind of revision. This is just like this is just like I mean, you can pick up along the way, but I think one good thing is for people that we did the Python session, we already now understand what is NumPy, Pandas, what is, so it will be easier. So I urge you, if you have not gone through this NumPy, Pandas to at your spare time, just try to get good understanding of them. But we'll go through. You don't need any background now. Python and previous background, we will use them as well. So yeah. Any question before we go on? All right. So if there's no question, we'll stop here. And tomorrow we will continue from the chapter of the book, how we can run a simple machine learning algorithm to see how it is work. So try to set up your environment so that when we come, while we were doing, or you are also practicing yourself. Yeah, thank you. So we'll end here today, and we see tomorrow at the same time.
Thank you.
Any question? All right. So see you all tomorrow. Bye-bye.